Hi, I'm Prof Al, and welcome to Chemistry Matters. And today we're going to continue on from the last video where we talked about the mole. A quick recap on that. The mole, remember, essentially was just a number. In this case, a very, very large number, 6.022 times 10 to the power of 23 anythings. So today we're going to look at how we go about using this whole concept of the mole. And in particular, we're going to concentrate on molar mass, which again, if you go back to the last video, was something that we introduced as being the mass of 1 mole of whatever it is that you're interested in. Okay, so how do we get our molar masses? We simply go to the periodic table. And if you look at the periodic table here, for example, you will see these numbers under the elements, and they are in fact the molar masses of each of the elements. Now, some people call these atomic masses when they're referring to elements. Molar mass in this case is the same thing, so no need to get confused with that. So let's look at a little example to begin with, and let's, for example, calculate the molar mass of something as simple as sodium iodide. So we do that by going to our periodic table. We look up the molar mass of sodium, and we see that the molar mass of sodium is 22.99 units, remember, grams per mole, and the molar mass of iodine is 126.9 grams per mole. And if we go ahead and add these up, we are then going to get a molar mass of 149.89 grams per mole. And that's the molar mass of sodium iodide. So we do the same for any compound at all. We simply go to the periodic table and we get our molar masses. Okay, so how do we use molar masses, and how do we relate the molar mass to the mass and the number of moles? Well, we do it through an equation, and that equation is one of the most important in all of chemistry. So if you're going to remember one equation in chemistry, remember this one. It's the equation for molar mass. Molar mass has the symbol big M, and we know that the unit of molar mass is the gram per mole. Okay, and if you think back to the video that we did looking at dimensional analysis, we can then figure out what our equation is going to be. Molar mass has units of grams per mole. What do we measure in grams? We measure mass. What do we measure in units of mole? Well, that's amount of substance, which we abbreviate small n. So there, and I'm going to put this in a red box because it is such an incredibly important equation. Molar mass is equal to mass divided by amount of substance, okay? Mass, remember, units of grams. Amount of substance, units of mole. The unit of molar mass, the gram per mole. This is one of essentially 2 equations in the subject that we're going to call stoichiometry that you have to use in stoichiometry. Now, over many years, I have seen this equation written every which way incorrectly. So please, please, please don't get it around the wrong way. And again, if you use that little trick, if you remember your units, you're going to be absolutely fine. Let's now use this equation in a real life example, and we're going to talk about the world's biggest faceted diamond. And this is the thing called the Golden Jubilee diamond, and it has got a mass of 109.13 grams. That's a lot of diamond. Now, as hopefully you know, diamond is pure carbon. So the question then becomes, okay, our Golden Jubilee diamond has this mass. What amount of carbon is contained in this 109.13 grams of this diamond? Or in other words, what number of moles of carbon does 109.13 grams correspond to? So how do we go about doing that? Well, we're going to be using this equation here. So big M, little m upon n. Now, what do we want? The question asks us for an amount, or to put it in other words, a number of moles. How are we going to do that? We need to rearrange our equation to make N the subject of that. What we're going to be doing is multiplying both sides by little n and dividing then both sides by big M. Okay? And if we do that, then we're going to find that n, which is what we want, is equal to little m divided by big M. Don't get your little m's and big M's mixed up. It's easy to do. Remember, little m is mass, big M is molar mass. So once we've rearranged our equation to get it in this particular form, then we can calculate our amount. So the mass of this diamond is equal to 109.13 grams, and the molar mass is the molar mass of carbon. So we go to our periodic table, we find the molar mass of carbon, and we find that that is 12.01 grams per mole. We now do our quick mental calculation, as we often do, and we find that this comes out to 9.087 mole. Okay, a couple of points about this particular calculation. The first and really important one is look at our units. Okay, we had to do a rearrangement of this equation during this calculation. We know that our units are all the right way round because this is the right way of writing this. The unit, remember, of molar mass, gram divided by mole. Here we have grams divided by moles. Now, to make sure that we have rearranged our equation correctly, we need to make sure that our units work. Do they? Well, we're after number of moles, which has units of mole. Here is our unit of mass, which is grams. Here is our unit of molar mass, which is grams per mole, or grams over moles. So what's going to happen there is that our grams on the top line is going to cancel out with grams on the bottom line. We have a mole to the -1 left on the bottom line. So that's a 1 over mole. So essentially what we have is 1 over moles, which comes out to be moles. Okay? And so in other words, we have our units correct. That means that we must have rearranged our equation correctly, and so we're all good. Take-home message here, 109.13 grams of carbon corresponds to 9.087 moles of carbon. Right, so let's expand, I guess, a little bit further on this whole concept of the relationship between number of moles and mass and molar mass. And let's say that we have got 3.50 mole of water. What mass does that then correspond to? Okay, so we go back to our trusty equation and we say, okay, so the mass that's going to correspond to that is equal to the number of moles, or the amount, multiplied by the molar mass, big M. So the amount that we have is 3.50 mole, and we're going to multiply that by the molar mass of water. Where do we get the molar mass of water from? We go to the periodic table again, and we say, okay, the molar mass of water is going to be 2 times the molar mass of hydrogen, which is 1.008, plus the molar mass of oxygen, which is 16.00, and that's going to have units of grams per mole. And if we do that, we get 3.50 multiplied by this number here. And so therefore, this works out then at 3.50 mole multiplied by 18.016 grams per mole. And again, we do the maths and we come out with 63.1 grams for that. So that is the mass corresponding to 3.5 moles of water, 63.1 grams. To finish up with, let's look at now the relationship between this whole idea of numbers of moles, of amount of substance, and the actual numbers of atoms or molecules or whatever it is that we're talking about. Okay, so let's then ask the question, if we've got 3.5 moles of water, what actual physical number of molecules of water does that correspond to? Well, in order to answer that question, we need to remember that thing called the Avogadro constant. The Avogadro constant was equal to 6.022 times 10 to the power of 23 per mole, multiplied by 3.50 mole of water, and that then gives us 2.11 times 10 to the power of 24 molecules of water in 3.5 moles of water. So there is the relationship between the number of moles and the actual number of entities that we're talking about, okay? So 3.5 moles of water, we're going to have 2.11 by 10 to the power of 24 molecules of water in that, okay? And to finish off, how many atoms then? How many atoms are present in this 3.5 moles of water, okay? So to know that, we've got to realize that each molecule of water is made up of 2 hydrogen atoms and 1 oxygen atom, so that makes a total of 3 atoms in every molecule. So therefore, the number of atoms that are present in 3.5 moles of water is going to be 6.022 times 10 to the power of 23 per mole, multiplied by 3.5 mole, multiplied by 3, because we have 3 atoms in every molecule of water, and so therefore that's going to give us an answer of 6.32 times 10 to the power of 24 atoms. So those are the absolute fundamentals of stoichiometry, and those are present in a whole lot of other videos in this series in which we do calculations involving numbers of moles, masses, and molar masses. So hopefully you've got your head around these fundamentals. Remember, that's a really important equation. Big M is little m divided by little n. Commit that one to memory if needs be, or at least be able to work it out on the fly. So hopefully you're a little bit clearer about this whole concept of amount of substance, numbers of moles. We'll see you next time.